Welcome to Dear SQL DBA, a podcast and YouTube show for SQL Server developers and database administrators. I'm Kendra Little from SQLWorkbooks.com. Today, we're talking about wait stats in SQL Server, specifically how you can find queries that drive those wait stats. Here's our question. Dear SQL DBA, there are many articles and how-tos about SQL Server waits. Plenty of scripts to check for the biggest waits and the wait types, and even the waits for a given SPID that's executing. But how do I find the exact queries which are causing my waits? I'm using SQL Server 2008 R2. This is a great question because waits are a really useful tool to figure out if you're having a performance problem, what's slowing your SQL Server down. When we talk about why is SQL Server slow, we are really talking about what is SQL Server waiting on. And figuring out what queries are doing the waiting can, in many cases, help us figure out what's causing the wait or learn more about what's impacted by the wait, depending on the type of wait stat it is. Now, we've got a lot of different tools in SQL Server, and this has evolved over different versions of SQL Server. Like our questioner, sometimes we aren't working with the latest and greatest SQL Server. Sometimes we're still on an older version like SQL Server 2008 R2. One thing we can do is figure out what are the current waits for queries that are running right now. Like the question says, you can say, hey, what are the waits for a currently executing session? Similar to this, you can say, I want to see the waits for every query that is executing or has an open transaction. You know, for everyone who's doing something right now, are they waiting? And if so, what are they waiting on? You can query SQL Server's dynamic management views to figure this out. And you can write custom queries, but there's lots of cool free tools out there too. I personally really like SQWhoisActive, which is a stored procedure by Atom Mechanic. It's totally free. You can download it at whoisactive.com, and it'll show you what's running, how long has it been running, what's the T-SQL, if it's waiting on something, what is it waiting on, if the wait type is a lock wait, who is it blocked by, and you can even do things like change parameters and say, hey, can you give me the query execution plans for these queries that are running too? Now, this isn't perfect. It's not that SQWhoisActive isn't perfect, it's that the information we get from the DMVs, there's little gaps in them. For looking at who's running right now and what are they waiting on, you get the waits from a dynamic management view called sys.dmos waiting tasks. This DMV is what are the waits for things that are running right now. And the thing is, it shows what's called resource waits. This is most of the waits in SQL Server, but it's actually not every single wait. For example, there's a wait called SOS scheduler yield. This isn't a resource wait. It has to do with the cooperative scheduling in SQL Server. Your queries, behind the scenes, they voluntarily, after they spend some time and do some work, they voluntarily yield the CPUs because it's not just first in, first out. I mean, right, I might have one query that starts at 5 o'clock and it's a really long query and it takes a lot of time. If I have a really short query that starts 1 second later, do I want to have to wait till the really long query is done before the really short query can even start? I don't. So SQL Server does this cooperative scheduling in which queries will periodically yield, and if there's a lot of stuff running, we might have to wait in line to get back on a CPU. We might have SOS scheduler yield. We're yielding and we're waiting for a scheduler to become available. This isn't technically a resource weight though, and you won't see it in sys.dmos waiting tasks. So I could have this weight on my instance, but if I'm looking at currently executing queries, I won't see them showing this weight while they're running, because think of it this way. SOS scheduler yield is technically a wait where I'm waiting to be active. I'm waiting to get back onto a CPU. There's more ways to tie together queries and wait stats. We can trace them. You can trace wait stats and the wait stats by a query with extended events. And I've done this before and found it really useful. I had a case where I was helping support this really busy system, extremely busy SQL Server, very, very high batch requests per sec. And we monitored the wait stats. We started to have a growing amount of CMEM thread waits. This is kind of an unusual wait type, especially to have larger amounts of it. It might be normal to see just a little tiny amount of it periodically, but we were seeing more and more every day, and it was the amount of time that we had per hour or per minute was notable. We were actually increasingly starting to wait more and more on this. And one of the first questions we had was, okay, well, we've got this weird CMEM thread wait. Is it just one query that's causing this? Is it just a few queries? Or are all queries having this? I couldn't see from SP who is active, I couldn't see this wait there. It seemed like when it happened, either I wasn't sampling at the right time, or maybe it was just too fast for me to notice, but I wasn't sure. So extended events helped figure this out. But I had to be super careful, because when you trace waits with extended events, it is very easy to generate just a huge wad of trace data. It is very chatty and very detailed. And like I said, this was an extremely busy system. So you can, when you're tracing, just sample and say, okay, I don't want to get weights for every query that's running. I want to try to get a different sample. And had to figure out kind of the right delicate sample size to be able to collect some of this information and only do it for a certain amount of time so that we didn't impact the performance of the system. Now, the SQL Server in question was actually a SQL Server 2008 R2 instance. And you have extended events at that version of SQL Server, but you don't have a GUI. So you've got to carefully craft scripts and hand shred XML lovingly. There's very few people who love to work with XML. So it took some time to work through and to test and make sure we were doing it safely. It did help answer that question. And in fact, in this case, it was actually all of the queries that were pushing toward this CMEM thread wait up, not just some queries. And that helped inform us as we went down the road of diagnosing and resolving this wait type. But so while you can trace them, because it generates so much trace data, and you have to be careful not to impact performance of the system that you're tracing, plus when you have that big volume of trace data, just going through it and querying it and analyzing it is cumbersome and time consuming. It's not super fast. So I use tracing of weights by query very selectively, and I'll usually try to look for a shortcut because it is time consuming and can impact performance. So if I can have a shortcut that's lighter weight and quicker to use, I'll totally go for that. I also, as I'll explain later, usually want more than just what's the query and the associated weight, because that doesn't help always figure out the cause of the wait. We'll talk more about this soon. So other techniques of tying queries to weights are you can make educated guesses about some of the common weights and kind of figure out, okay, what queries are most likely to be driving up this weight. And then with some more dire or more rare weights, you can set up some kind of crafty solution, sometimes using alerts and perf counters. I'll give you some examples of those. Let's talk about some of the most common weights and how you can guess at what queries drive them up. Now, this method of guessing isn't perfect. I'm talking about using dynamic management views like sys.dmexec query stats in SQL Server. This dynamic management view and its friends that collect execution plans, they have lots of great information about how much CPU has been used, how much reads queries have done, what the execution plan is, what the T-SQL is. But these dynamic management views don't have everything. They get cleared when you restart the SQL Server or it fails over. Memory pressure causes information to fall out of them so that they don't just take up an endless amount of memory on your SQL Server. And things like recompile hints and queries can make things not show up in them. But it's really fast and easy to use these, and they do have a lot of information about what's been running in your SQL Server, and accessing them has a low risk to performance. So it's not perfect, but it's really, really good. And most of the time, it can get you most of the way to where you need to go in figuring out what's causing some of these very common weights. One really common weight is CXPACKET. The CXPACKET weight type is specific to parallel queries. You only will get CXPACKET weights from queries that have parallelism. And one of the things about parallel queries is that they typically have a higher average CPU time than their average duration. So think about it this way. I have a query that runs for 1 second, and for that 1 second, it uses 2 cores. It may use 2 seconds of CPU time, right? Because we're counting the CPU time for both of those cores for that duration of 1 second. So I have a higher CPU time for that parallel query than I do have a duration. If I'm looking at sys.dmexec query stats, I can see how many times a query is executed and its worker time, aka CPU time, as well as its duration. And I can figure out, hey, just do a little division. What's the average CPU time for this query and what's the average duration? So if you sort your query, if you say, okay, I want to see all my top CPU using queries, I'm going to sort by, total CPU descending, and then you look at average CPU time and average duration, you can pretty easily guess at which of your queries are most likely parallel because their average CPU time is higher than their average duration. The ones that are using the most CPU overall on your instance are very likely the drivers of your CXPACKET weights. And you can look at those queries and test them out on a test system at different max stops. You can measure out how much, hey, okay, I'm gonna measure out what are your weights when I give you a test run. Now, this has become easier to measure when you are running a query in recent versions of SQL Server because in SQL Server 2016, they've started to put weight stats in our execution plans if you run a query with actual execution plans on. So you've got to give it a run with actual execution plans, but then you can even see information about what your weight stats are. Another common weight type is PAGEIOLATCH weights. Now, this is PAGEIOLATCH, so it's important that it has the IO in there. There's other similar named weights. The IO, PAGEIOLATCH, means, hey, I had to go out to storage and pull pages into memory. I wasn't able to just do a logical read from pages that were in memory. For the data I was working with, I had to go do a physical read and pull the data into my buffer pool in memory. Now, who's the biggest suspect for PAGEIOLATCH weights? Well, that would be your queries that do the most physical reads. You can see in your dynamic management views, sys.dmexec query stats, It has information about logical reads, about physical reads, and about writes. So you could say, I want to see the queries who since startup, if you want your SQL Server to have been up a while, because you don't want it to have just been the queries that had to do physical reads when we were just starting up because our memory was empty, right? But overall, who are my queries who've done the most disk access? Those queries are suspects for perhaps driving PAGEIOLATCH weights. You might want to look at the execution plans for those and look for scans of large tables. Do they really need to be doing those large scans? Is it missing an index? Those are, these are the suspects for things like that. Now, you can get more complex when troubleshooting PAGEIOLATCH weights. We're gonna return to this one because this is sort of the simplest way, and it could have some false alarms in there. So we'll circle back a little later and talk about how some PAGEIOLATCH weights could be a little misleading and you might want to avoid them. Other weights that are common are lock weights. Lock weights are associated with being blocked. So this is one of those weights where if I'm looking for who's having the weight, I'm really looking for who is being blocked. And really, if I see LCK weights and it's LCK underscore M underscore whatever the weight type is, one of the things I want to know is just who's blocking who. And there's some built-in tools that can make that easier. Things like the built-in blocked process report. We've had this in SQL Server for a long time. It's just not everybody knows about it, but it's a built-in tool that you can configure so that SQL Server emits a report when the deadlock manager wakes up and sees blocking. You have to configure this and you have to configure a trace to pick up the report. You got to do a little bit of work, but then the report will tell you things like who was blocking, how many sessions were blocked, and give you things like the input buffer of those sessions. I've got a course called Troubleshooting Blocking and Deadlocks in SQL Server at SQL Workbooks that walks you through setting that up. You can also just do a search on the internet, look at books online, and figure out how to use the blocked process reports. What about times that we need to get crafty with weights that are more rare that we don't see all the time? Sometimes we can get these really dangerous weights that, if we have any significant amount of them, make the SQL Server seem like it's not even working. With these weights, it can be really critical to figure out what the heck is causing this weight to happen, because when it happens, things get really slow, customers complain, and queries can hardly even get started. One weight like this is called resource semaphore. And I think the first time I ever saw resource semaphore was way back in SQL Server 2005. It's like I've been chasing resource semaphore and it's been chasing me for more than 10 years now. The resource semaphore weight happens when you have a very specific type of low memory condition. Your queries in SQL Server need memory to just process the data through the query. So, for example, if you need to sort the data in your query, you need a certain amount of memory to be able to sort that data. You also need memory for certain types of joins. If your query goes parallel, that requires some memory too. This is called query workspace memory. And SQL Server has to be kind of careful because you don't want a query to just run out of memory while it's running. So when your query is going to get started, it has a requested amount of memory that it wants to get allocated. And it's actually pretty smart about this. It has an ideal for it negotiates. It's like, okay, well, here's how much memory I'd really like, but there's an amount I would settle for too. But that settle for amount is basically a minimum. And it's like, I really should, if I can't get my minimum amount of memory, that settle for amount, I really shouldn't get started. So resource semaphore weights happens when you've got queries who want to get started, but they can't even get their minimum settle for amount of query workspace memory, and it's just not safe to let them get started. And this is because typically you've got other queries running who are using memory for query workspace memory, or maybe that query who wants to get started, it might be asking for an awful lot too. But usually you're going to have outstanding requests, as well, because if there was a ton of that memory available, and the amount of it available does depend on the amount of memory your SQL Server has, if all of the memory was available for my query workspace memory, usually I could get started. So this can be tricky because if you really start having a lot of these waits and you try to connect to the SQL Server and run a query to see what's happening, it is possible that the query you're running to see what's happening needs a memory grant. So you might have to wait too if a lot of the query workspace memory is in use. Now, you can connect in a special way using the DAC, or the dedicated admin connection. Only one administrator at a time, and it's only administrators, can connect to the DAC, but it has reserved memory allocation and CPU resources. So if these things are low, you can still get in there and be like, hey, what's up? But you can't always connect to the DAC right away. So I had a case where this wait was happening, performance was getting really bad. And what I did is we set up a performance alert in the SQL Server agent that looked at a perf counter called Memory Manager Memory Grants Pending. Or actually, there's two counters. There's Memory Grants Pending, and there's Memory Grants, I think I've written down the wrong counter. There's Memory Grants Pending, oh, no, I am right. And there's Memory Grants Outstanding. I was like, am I remembering the right counter? Memory Grants Outstanding are grants that have been granted and they just aren't done yet. Memory Grants Pending is in fact the ones where like, I've asked for my grant, but I haven't gotten it yet. So I set up an alert for when that counter was greater than 0. And when that alert fired, I told it to kick off a SQL agent job. The agent job ran SP who is active and wrote the results to a table, and it ran a couple other diagnostic queries too. You might wonder, how did that job manage to run? Well, as long as there was just one pending memory grant, I could get that job to run and get some information to a table. It's really when, at least on the systems I usually see, I've seen cases where it's, the wait, we have some resource semaphore waits, and some queries are getting queued. They can't start because they can't get their memory grant. And it's really as that builds up and gets worse and worse that even little queries can't run. Usually you can get smaller queries to run. I could get SP who is active to run and figure out, okay, when this wait type starts, what queries are executing, what is their execution plan, how much memory do they have, and then some other information to figure out who is it that's causing this condition. A similar really problematic wait is thread pool waits. SQL Server, if you create a lot of active threads, and this isn't just connections. Connections, you might have sleeping connections that aren't doing anything. This is active sessions who are connected and are doing stuff. If you generate enough of those, you can actually get to a point where SQL Server is like it dynamically, by default nowadays, it dynamically figures out how many threads are safe for it to use based on your CPU count and some other factors. And you can get to a point where it's like, it's not safe to create any more threads. We might cause instability with the operating system. And you get waits to create threads because you've got queries coming in and it's just not safe to create more of these. This can be caused by issues setting up connection pooling, or blocking in SQL Server can contribute to this too. For some applications, you could have a case where you have a lot of blocking and you've got these active sessions, they're blocked, but they're trying to run stuff. They're waiting on a lock resource and you get lots of them. And the application's response is just to try starting more stuff on more threads. This can also cause thread pool waits. And maybe this, in these cases, often the more threads it's creating get blocked too. What I did in that case was set up a SQL Server agent performance alert looking at the general statistics processes blocked counter. I said, okay, when we've got blocking, I want you to start this job. And the job logged the results from SP who is active to a table and also some other dynamic management views because I wanted to see if I could catch the start of when thread pool was happening and confirm if it was blocking who was leading into this. Timing is everything. And I should say, if you're capturing information from the DMV's two tables, you also have to be careful about how much data you're capturing because a lot of these things like the T-SQL for queries or execution plans, they can be stored as large pieces of XML and you can easily fill up a database and fill up a drive. So you gotta be really careful when you're collecting this data, but it can help you trap the information and try to be tricky about seeing the incident as it's starting before it gets to that critical point where it's difficult to run queries. One of the other tricky things about this is that knowing who is doing the waiting is often not enough. Revisiting the question. The question is, how do I find the queries which are causing my waits? Well, the query who has the wait type on it is not always the query who is causing the wait. It may be the innocent bystander who is suffering the wait that was caused by a different query. And that different query, maybe it had a wait, maybe it didn't. So here's some examples. That locking wait. The query who shows an LCK wait is blocked by someone else. It says, I am waiting for this resource. What we really want to know is who is at the root of the blocking chain, right? Who was holding locks for long enough that it blocked one or more other queries. They didn't have a lock wait though. It's the victims who have the lock wait, and maybe there's a whole chain of them, right? Maybe I have a lock wait and I'm blocked by someone else who also has a lock wait who's blocked by someone else. So we could have a long chain. Similarly, the query that shows a resource semaphore wait is the one who's saying, I can't get my memory grant that I need. I can't get an allocation to get started. We might want to look at it to see, are you asking for something completely unreasonable? But we also want to know who else is running, who doesn't have this wait, and what memory grants do they have? And what memory grants are they consuming? Because they are part of this problem too. Even for PAGEIOLATCH waits, I gave that simple example of, okay, I want to know who has the most physical reads, but just because queries have PAGEIOLATCH waits, or just because they did physical reads, doesn't mean they necessarily started the problem. Maybe we've had a restart and we're populating our buffer pool because it was cleared by the restart or failover. Or maybe, for example, there was a bunch of queries that caused a lot of memory churn in our buffer pool, like 15 minutes ago. And, they populated the buffer pool with all these pages which aren't usually needed by our queries. Well, after that happens and other normal queries start running, the pages they need are no longer in memory anymore. So they got to go populate the buffer pool and read from disk too. So they might have PAGEIOLATCH waits, but they didn't cause a problem. It was those queries 15 minutes ago. So not every, in the case of PAGEIOLATCH waits, some of the queries who have this maybe cause the problem, but not all of them. If I am in a situation where I'm wondering, okay, who took over the buffer pool? There are ways I could figure this out. There's a performance counter called Buffer Manager Page Life Expectancy. And It indicates an estimate of how many seconds a page is likely to be able to stay in your buffer pool. There's no magic numbers for this counter. I wouldn't say this counter should always be above X. What I would do, it's great to track for trending because you could do something and say, okay, well, I want to see what time was it when my page life expectancy started to drop? Like, what time was it when this started to take a nosedive, and what queries were running around the time that that happened? That's not necessarily just saying who's got the PAGEIOLATCH weights, right? It's more complicated. In other words, to really figure out how to use our weight information, we need a lot of context, and it's more than just the queries associated with the weights. We want to know, ideally, what's executing or holding an open transaction, right? Because I actually could have a query that's just sleeping and holding locks. What is their session status? Are they sleeping? Are they running, etc.? What resources are they using? What are their weights? What are their execution plans? The more of this information I have, the better. And this is why monitoring tools for SQL Server are so helpful and so popular, because as a mature product, SQL Server enjoys having a lot of mature monitoring tools where companies have figured out, hey, having all this information really helps you troubleshoot problems. And they collect weight stats. They collect what queries are executing along with their execution plans. They collect who's blocking who. So you can go back to 3 o'clock when you were out for a cup of coffee and say, okay, what were the weights, who was running, and try to tie that information together. Having all that information in an easy to use graphical tool makes it much easier to make these educated guesses. So that's why these companies are so successful selling these products. And there's several very, very good products that do this. SQL Server is going to make your life easier, though. If you don't have the budget to invest in these products, you can use things like the crafty workarounds that I've talked about, right? Because in those situations, we didn't have a monitoring tool. We had to come up with a crafty workaround to use an extended events trace or set up a job with a perf counter to collect the information ourselves. But in the future, I probably won't have to be so crafty because the query store tool that was introduced in SQL Server 2016 is getting better and better. And one of the features that's coming to Query Store in 2017 is that weight stats information is going to somehow be integrated into Query Store. And I actually haven't kicked the tires on this yet. It's something I'm really interested in trying out with vNext. This is fantastic because Query Store is available in all editions of SQL Server. You don't have to have expensive edition. You can configure it by database. It restores with the database, so it's portable. And the ability to have information on what was the execution plan at this time and some information on what weight stats went along with the query is very likely to make life much easier. Now, I don't know for sure. I doubt that Query Store is going to replace fully those monitoring products that I'm talking about because those tools are very, very rich, and Query Store has to be careful about not bloating up your database too big. So it'll be interesting to see, but very, very likely that something is better than nothing in terms of the weight stat information. Even a minimal implementation is going to be helpful. So I'm very excited about trying that out. And I am very excited that the investments are being made in this area as well. So thanks so much for this great question about weight stats and queries. It's not an easy thing to do, but it is worthwhile. And the adventure teaches you a lot about performance in SQL Server. If you are listening and you've got a question about performance or anything, it can be a real simple question about SQL Server. It can be about office politics. Hit me up at sqlworkbooks.com/ask. I'd love to get your question. Thanks for joining me for Dear SQL DBA. It has been a pleasure as always. I am Kendra Little from sqlworkbooks.com, and I'll see you again.